Hello everyone. This video walks through completing Packet Tracer Assignment 8.1.3.3, Configuring DHCP Using Cisco IOS. This Packet Tracer assignment is a part of the Cisco RNS Routing and Switching Essentials Curriculum version 6. Now, in this particular lab assignment, we are going to configure DHCP, Dynamic Host Configuration Protocol, using our Cisco router. Now, there are other ways to do this. You may have done this with like maybe a Windows server or something like that. But basically, the idea is for our end devices like our PCs and things that don't need a static IP address or one that needs to be the same all the time, they can auto request an IP address from the DHCP server, which in this case is going to be R2. So all of our devices are going to be requesting DHCP addresses from R2, and they're going to get them based off their respective network. Now, let's think back to all the countless end devices that we've assigned IP address into so far. We will usually go into PC1 or whatever end device, assign it an IP address that was usable, a subnet mask that was associated with that network, a default gateway that it needs to talk to that router so it can get outside of its own network. And in real world situations, you would need to assign like a DNS server so that you could resolve those URLs that we type in like google.com to whatever IP address it is, right? So we don't have to walk around remembering a bunch of IP addresses to websites. So we can actually have PC1, when we click DHCP button here instead of static, grab all that information for us based off of what's available out of what we call the DHCP pool that is hosted on R2. So R2 is going to host a DHCP pool for this network over here with R1. It's going to host one for this network over here with R3 because these are not in the same networks, okay? So we have two DHCP pools here on R2, but think about it. How does R2 know which one of these are the 192.168.30.0 or the 192.168.10.0 network? How do we prevent PC1 from getting an address from this pool? We're going to set up a helper address so it'll know which one is with which respective network, okay? Then we'll also show you in this lab, how does this interface here on R2 get an address automatically? Maybe it gets a DHCP address from the internet, kind of like we do at home. Like I don't pay for a static IP address that always stays the same at home. I lease one from my internet service provider for a certain amount of time, then it'll renew, or every time it powers off, it'll renew, and just grab a new one, right? Whatever's available. So let's get started here first. So R2 is going to be what's called our DHCP server. That's the one that's going to be handing out the addresses and responding to the DHCP request. So we'll go into configuration mode, and first you have to think about excluding addresses. Why would I want to exclude them? Well, there are certain addresses here like my default gateway on R1 that will not change, okay? There could be also ones in your network, like maybe a network printer or something else that you don't want to change. You always want it to stay the same. You need to exclude those addresses because if not, it could automatically get assigned out at random to an end device like a PC, and you can't have overlapping addresses on your network. Remember, you can only use that usable address once. So first, we're going to exclude the first 10 addresses from both DHCP pools we're going to have, okay? So the first thing you want to do is look at what is our usable addresses over here, right? So it's 192.168.10.0 through 192.168.10.255. We know that based off of our subnet mask, which is a /24 here, okay? And then over here, 192.168.30.0 through 192.168.30.255, right? Now, that's network. Let me rewrite that one more time. Forgot my dash. 192.168.30.0 through 192.168.30.255, okay? Now, that's network to broadcast. What are our usable? So our usable over here, it starts at 192.168.1, or sorry, .10.1 through 192.168.10.254, because you can't use or assign the network or broadcast to a end device. Over here it's 30.1 through 30.254. All right. So we've got that for both networks, right? So if we want to exclude the first 10, you got to think in terms of usable. You can't use the network in the broadcast anyway. So to exclude the first 10, our command is IP excluded IP DHCP, and then you see excluded address, and then we're going to put the high and low. So the low address here is where we want to start excluding is 192.168.10.1, okay? And then you want to put the high end of that. So 192.168.10.10. That would exclude addresses 10.1, 10.2, 10.3, 10.4, 10.5, 10.6, 10.7, 10.8, 10.9, and 10.10. If you count those on your fingers, that is 10. All right. So we're going to exclude those addresses out once we set up our pools. And we haven't set up our pool yet, but you won't be able to assign those. So what will happen is when PC1 starts requesting, it's going to look at, okay, this is my range, this is my usable range, but I'm excluding .1 through .10. So they're no longer going to be available in our pool to send out to other computers. Now I'm going to repeat that command, but I'm going to do 30.1 through 30.10 because I want to do the exact same thing over here for this one eventually. Okay, so it's IP DHCP excluded address. You put your high to low, so it's going to exclude everything between those two. All right. Next, it says to set up the pools. Okay, so I'm going to set up two. This one is going to go over here for R1, S1, and PC1. So IP DHCP pool, and then you're going to put a name, R1-LAN. Now these are case sensitive, so make sure you put them in there correctly for Packet Tracer to grade them. All right, now we're going to configure the pool to include a network address. Now you see here it says DHCP config, so I'm going to hit a question mark. Some stuff that you can assign here is the network. So what is my network? 192.168.10.0, 255.255.255.0. What that tells my router again is what my network range is because of the subnet mask I put in there. But we've excluded the first 10 addresses so it knows don't assign those. Now we can set up a default gateway. The command for this one you see is default router though, okay? So it's default router 192.168.10. And then if you look up here, all right, 10.1 is G00 on R1. G00 on R1 is this port right here. So that's my default gateway for that network, right? So you got to still use those skills of identifying what is the default gateway. Okay, we need that in there. All right, what else? It says to assign the IP address of the DNS server. So this, we're just playing like this DNS server really works here. In real world situations, you definitely would need one. And the command is DNS server. And then you just put the IP address, 192.168.20.254. Now, sometimes people like to use like Google's, which is like, I think like 8.8.8.8 or something like that. Or you'll have one that is automatically assigned to you from your internet service provider. Okay, so all those pieces of information will be automatically given to a computer when they request it. Okay, now let's set up our other DHCP pool. So IP DHCP pool, and this time this one is for this network over here, R3 to S3 and PC2. Okay, so IP DHCP pool R3-LAN. It tells us that in our directions what to name it. Okay, and you're going to set up similar information, except this time our network is 192.168.30.0. 255.255.255.0 is a /24 subnet mask. We're going to set a default gateway. So we'll do default router 192.168.30.1 happens to be the IP address of G00, okay, which is this address or for this interface right here, which is our default gateway for this little network here. Okay. And then I can actually set the exact same DNS server okay? Because again, that can field request from pretty much any PC that's on the internet, okay? So that doesn't have anything to do with your specific network. Okay, so what's going to happen is PC2 is going to ask, and when I set it to DHCP instead of a static, it's going to send out a DHCP request, and R2 is going to eventually respond to that with this information. Okay. All right, so we got all that in there. Next, we're going to configure DHCP relay. Now, we got to configure R1 and R3 as DHCP relays so it'll know where to send this information accordingly. Okay, so on my interfaces here on G00 and G00, so both of these are G00 on R1 and R3 right here. We need to set up what address this corresponds to right here on the other side of it, okay? So when it gets the request, when PC1 sends out this request and R2 responds to it, it needs to know how to get back to this side of the network. The only way to do that, to know which pool is which, is if we go into R1 and R3, we go to interface G00, okay, which is right here, and we set up a helper address. That's what a relay address is. So we actually do IP helper dash address, and then it's looking what was the destination address. Well, right here on R1, this S000 is going to be 10.1.1.1, okay? I'm sorry, 10.1.1.2 is the other end of R2. So right here, S000 on R2. So it's going to be that address right there. Okay, so it knows where to receive this information from. Then next on R3, we need to pretty much do the exact same thing, but put this side of R2, that goes away. So on this side, it's S001, okay? So interface G00, IPE helper address 10.2.2.2 is R2's S000 interface. Okay, so again, R3, when it sends that request out from PC2 saying, hey, I need an address from your DHCP pool, it's going to send it up here, and it knows to correspond basically this network with that side of R2, this network with that side of R2. So it'll know, hey, PC1 is not trying to get an address in this pool because both of the pools are up here on R2. It doesn't know which way to go unless we put that helper address with the network. Okay, so again, those are the addresses: IP helper address 10.2.2.2 on G00 on R3. R1 is IP helper address 10.1.1.2 on interface G00. Okay. Lastly, it says how to configure R2 as a DHCP client. So what if R2 right here, this what is that, G01 interface on R2 needs to get an address automatically from the internet? Well, how would we do that? Usually we go into interfaces and we put IP add, right, and we put the IP address and subnet mask. But notice this option, DHCP. What that does is it allows us to be able to tell that interface, and you see it just formed a new adjacency. It allows us to be able to get an address automatically from somebody else. So it basically sends out a DHCP request for whoever's listening, and that happens to be a router here in the internet cloud. So we just got an address for this interface, okay? And if you do a show run, you actually shouldn't see the IP address there. You should just see right here, IP address DHCP, right? Now, if you do a show interface G01, right, you'll actually see the address there, but you won't see it unless you do the detailed information. Okay. Now, we got all that stuff set up, but how does this actually work? So if we go to PC1, how do we get an address? Well, you click DHCP there, and if we got everything correct, you see all that information fill in. So it assigned the first available, which was 10.11, because remember 10.1 through 10.10 are all excluded. So it started at 10.11, gave us our subnet mask based off of our network, gave us our default gateway and a DNS server, okay, that we put in there. Then we'll do the same thing for PC2. Click the DHCP button and you see it automatically got a address in a different network or subnet, which was the 30. Okay, and again, it used that helper address, all right, to be able to relay that information. Now, obviously, we should be able to talk to R2. Now, if you don't get this fill in correctly, if it says like something failed or DHCP failed, whatever, and then it has like a 164 address or something, you didn't get it working. Plus, of course, remember, 100 out of 100. All right, so you want to make sure it's getting the information correctly and can talk to everybody correctly. Okay, so you definitely want to make sure you test that out. All right, that it can talk to all these different places. Okay. So again, that configures DHCP. We're using R2 as a DHCP server, as well as we're doing R1 and R3 as like a relay agent to relay the request back, responses back to PC1 and PC2, as well as we put the DHCP server here. We had a port as a DHCP client. Okay, so that concludes our DHCP lab for this chapter.